Okay, hello. Welcome to the second SOLUS webinar. This one's on recommendation systems. My name is Ramsu Sundararajan. I head R&D for SOLUS. I'm going to spend the next 45 minutes or so talking about how recommender systems are built, what are the kinds of concepts that go into it, broadly speaking, some of the broad strategies that we can talk about, and then move from there into some of what we do within SOLUS. What is SOLUS? I think most of you are aware. It's what we call a system of intelligence. So when you're looking at the problem of personalizing your engagement with customers, a broad functional taxonomy of the whole thing is to say, hey, there's a system of record that measures what people do, the system of engagement that figures out how to talk to them, and then there's a system of intelligence in the middle that largely focuses on what to do with what you know about your customers and figure out how to engage with them in a very personalized manner. Now, obviously, this is a functional taxonomy. Products themselves would overlap in terms of what they do. And one of the mainstays of what SOLUS does is get that intelligence right? So one of the mainstays of intelligence itself is a recommender system. So when you talk to people about personalization, very often recommender systems will enter the conversation. And we're all familiar with this because pretty much all of us have encountered this in some form or the other. So there's no real benefit in saying, hey, recommender systems are this great new thing and they're great and good and so on. Everybody understands this. What I want to do for a while, though, when we start, is talk about the kinds of things that underlie recommender systems or the reality of building recommender systems for businesses, and sort of, peel back the curtain a little bit to convey the real world messiness that sometimes underlies the whole thing. So let's get going. So one of the first concepts that I want to talk about is the idea that recommender algorithms and recommender systems are two very, very different things. Okay. Recommender algorithm is a very limited scientific sort of entity, right? It's an algorithm. Its job is to say, okay, I have some data. Can I use this, process it, and then figure out what to recommend to people? Okay. A recommender system, on the other hand, has to account for the mechanics of outreach. It has to account for a whole bunch of other aspects in terms of what are the circumstances under which you're talking to a customer or engaging with a customer. What are the circumstances under which the customer might respond and what exactly constitutes a response. So the plumbing for all of that and that entire system is what a recommender system is, right? So an algorithm could be a single beautiful thing that focuses on one objective and does very well on that objective. But a recommender system has a slightly larger scope. Okay, it's a fairly standard distinction of an algorithm versus a system. We're just applying the distinction here in recommender systems. And as we talk about recommender systems and what kinds of things they do, we will talk about some of the algorithms that go in, as well as the kinds of things that encompass the entire system. The next thing I want to talk about is the idea that when you have a system, we can talk about how well the system does, but it goes back to the whole idea of an algorithm versus system. Recommender accuracy can be a very specific analytical sort of metric. We can talk about, hey, I recommended 10 items. Did the customer buy at least 2 of those? Okay. Or the customer bought 3 items, where at least 2 of those in my recommendations. Okay. All of these are metrics that you can talk about, and these are very analytical metrics, and there are a variety of ways to compute. But recommender performance, on the other hand, is a multi-tiered sort of question, because you're talking about performance in terms of that analytical accuracy. You're also talking about performance in terms of, am I getting the customer to engage with the brand by getting on the website or getting on the app? Am I getting the customer to buy more? Am I getting the customer to buy more in the direction that I'm nudging him or her in? All of these questions become part of recommender performance. So there's a much larger question at play. So just like you have accuracy for algorithms, performance is a multi-dimensional sort of measurement that applies to recommenders in general. Okay, so that's another aspect to sort of keep in mind. Now, a lot of this would not be a surprise to most of you if you are decision makers in marketing and CRM. This is just to sort of reiterate some of the basic assumptions. Here's an interesting one, right? A customer might come and buy one product, but the reason to buy the product need not be, hey, I just want to buy something. People approach consumption in very different ways. Sometimes, and why does this matter to recommenders? Because when you're talking to customers, you need to understand that people approach consumption in very different ways. Sometimes, and let's take the example of eating out, right? Or rather ordering in, let me put it that way. So let's say you're sitting at home, Friday evening, 8 p.m., you haven't made dinner, you want to order in, you're opening up your favorite food aggregator app. Sometimes you're just in the mood to look at what's out there and then pick something. Sometimes you already know that you're in the mood for, say, Oriental food. Sometimes you're looking at it and you're saying, hey, I've never tried Mediterranean. I've never tried Ethiopian, right? Sometimes you're just going to go in and order something that you had already had that you know worked very well for you. So you would approach consumption in very different ways. And if you're going to approach consumption in very different ways, the way a brand engages with you in terms of what it recommends to you also needs to approach you in very, very different ways, because who knows what works, and then you have to sort of track that. So that's the whole idea of buying one product not being the same as having one reason to buy a product. You could have a variety of reasons, and each of those needs to be addressed differently. And the way that plays out is something that we'll talk about in a bit. Right? Now, this is an interesting one about a physical product and a logical product. Let me take an example of the airline industry, right? So in the airline industry, so let us say you have a flight that leaves from Bangalore to Bombay at 8 a.m. Let's say there's an Indigo flight at 8 a.m. from Bangalore to Bombay. Okay. And let's say as an airline, you've sat down and you've done your demand forecasting and all of that for this flight. Let's say for whatever reason, schedules have changed and this flight now leaves at say 8:10. Technically speaking, that's a different flight. But logically speaking, it really isn't, because the same set of customers are probably going to take that flight, which means that the demand for the 8:10 flight is pretty much the same as the 8 o'clock flight. The demand for a 9 a.m. flight may be different. But within certain boundaries, you can imagine that the logical product is something that leaves around 8 a.m. The physical product may be the flight that leaves at either 8 o'clock specifically, or 8:05 or 8:10 and so on. Now, how does this work out in, let's say, apparel? In apparel, for instance, you have a whole bunch of products. So you may have a lakh products in your product master. You could have even more, right? And you have a bunch of attributes by which you describe these products. Now, in some cases, the difference between two of those products may be fairly small. And in terms of their impact on what you talk to the customers about, it may also be very small. So sometimes it's useful to think of products in terms of slightly coarser grain, right? Just like a logical product is a slightly coarser grain than a physical product, the same thing could apply here, right? For instance, you could have, let's say, a cerulean sweater, okay? But if you're Miranda Priestley, it matters whether it's cerulean or lapis or turquoise, okay? If you're Anne Hathaway, it's just blue. Right? So it could well be that the granularity at which you look at your products and their attributes is far coarser than the granularity that actually exists. So a slightly different way of looking at this is to say that let me think of my products in terms of a combination of the attributes I use to describe them. Okay, so there could be a category and a brand and a subcategory and a size and a color and maybe a few other attributes. And then you put these together and you said, this is essentially what I'm thinking of as my product or my logical product, which is this combination of attributes. And that's a useful grain to think of, because then you could look at a variety of customers who've done fairly similar activity, and as long as what they've engaged with is either the same or very similar logical products, it allows you to understand their behavior in relation to each other much better. And this is fairly critical to recommender systems, because when you think about recommender systems, you're broadly talking about how do customers engage with customers, how do they relate to each other, and how do products relate to each other. It's broadly speaking kind of things that you look at. So if you can reduce your granularity a little bit, both from a computational standpoint, because you're dealing with less data, and also from a common sense standpoint, it allows you to understand your data a little better. It allows you to then build products that are slightly more robust to small changes. Okay, so that's what a physical versus logical product is. Now, within Solus, we use a term called the product genome. Okay, what we're referring to as a product genome is basically a unique combination of attributes that describe a product or a set of products, right? So every unique combination of a set of attributes that describe a set of products becomes a logical product or a product genome. And there could be a bunch of physical products that essentially link to a particular product. When you have a really small product master, sometimes the two can be the same. When you have a really large product master, then the distinction actually helps you computationally, logically. So another thing I want to talk about is essentially the aspect of outreach itself, right? So you have a variety of situations through which you're talking to customers when you have recommendations. One is a push-based system where you're essentially putting your recommendations into either an SMS or an email or a WhatsApp carousel, or you're putting it into some dynamic personalized link into a dynamic personalized page, and then the link to which is sent through an SMS or an email or WhatsApp. And you're essentially saying, hey, go look at this. These are our recommendations for you. Okay, and there could be a variety of tonalities to your message and so on, but this is push. The other is a pull. Now, a pull engagement is one where a customer is essentially visiting a website or an app. And once they visit a website or an app, they're essentially clicking on recommender widgets, they're clicking on product pages and looking at recommendations associated with the product and so on. Now, one of the critical factors that determine the quality of that particular interaction is the latency of response. So you want that response to be as quick as possible. So customers are browsing something, you're looking at that, they're going to a product page and you want to say below that, let's say people who bought this also bought yada, yada, yada. Okay, you want to do that in real time, but that does not mean that you have to make the calculation of these co-purchase patterns in real time. Okay, what that means when you build recommender systems is that you're asking yourself questions around, hey, I have these algorithms. Sometimes your algorithm choices depend on how much time you have to compute it, how big your computer is, and so on and so forth. You also have to sort of determine when do I compute it in order to be able to respond in real time. So can I pre-compute all my co-purchase patterns, which is the most standard way of doing it, so that you go to a product page, I pretty much know what are the co-purchase patterns I've already noticed and I know what to send to you. Right? Sometimes, however, you do need to adapt in real time. If I'm looking at your browsing behavior and adapting what I'm showing you based on the browsing behavior, then I do need to learn something about you based on your real-time behavior. So it's not always the case that the algorithms cannot be real-time and have to be pre-computed. Sometimes you do have to be real-time. So it's useful to sort of break it down and not think of it as one or the other. So far we've talked about a bunch of concepts. The one other thing I want to talk about is an aspect of real life data messiness. And really what I want to talk about here is there'll be a bunch of businesses where the majority of their business is offline. Okay. What that means is that your understanding of how your customers interact with your products is essentially your transaction master. And for a lot of those businesses, what would also happen is that for a very large proportion of your customers, you have essentially one transaction. Okay. Now, in the aggregate, you have a lot of data. So you're thinking in terms of, oh, I have so much data about all of my customers. Okay. But in reality, there are some customers for whom you probably have an embarrassment of riches because they've bought frequently, they use your app. So you have non-transaction intent data about what products they're interested in, what they browse, what they added to a wish list, what they added to a cart but did not buy, all of that. So for some customers, you have an embarrassment of riches. And there's like a good number of customers where, it's like a data desert, really. You have one data point for each of those customers, and that becomes your starting point. Okay, it's not exactly a cold start problem, but it's not tremendously far off either. So you need algorithms that know how to deal with situations where you have a lot of data and how to deal with situations where you have very, very little data. So you need that ability to automatically sort of flex. You have more data, certain strategies work better. You have less data, certain other strategies work better. How do you sort of flex? So all of those also need to be part of the considerations that go into a recommender system. Okay. So far, so good. So let's now maybe talk about what are the kinds of layers you'd have in a recommender system. The most basic layer, obviously, is the data itself, which is how do customers interact with products? The most obvious kind of interaction being customer A bought product B. Okay, so you have your transaction master. Now, there may be ways in which you have more characterizations of the customer, which could be, in some cases, socio-demographic variables. Although for a lot of retail businesses, that may not be the case. In businesses like BFSI, travel, and so on, you may have more information about the customer. Okay, so you have social demographic variables. You have information around the product, which is your product attributes, the physical product, logical product sort of thing that we spoke about a little earlier. You may have additional information that characterizes the transaction itself. Okay, and that could have a variety of examples. For instance, in a QSR domain, it could have to do with whether it was a dine-in or a takeaway or an app delivery sort of situation, an app-based delivery sort of situation. Okay, it could be a question of what your payment mode was. Okay, in say financial service, let's say you're a fund house, it could be a question of is it a lump sum or an SIP. Okay, in a QSR situation, again, it could also be around are you a weekday or a weekend sort of transactor, or are you a breakfast shopper or a dinner shopper if you're talking about food, right? So I could think of a variety of contextual aspects that go in. Some of the context may also be provided in certain cases by what other people do. So your context could also be what is that choice set that tells me whether or not you have a certain preference towards something that is more expensive or less expensive? Do you have a preference towards discounts and so on and so forth? So all of these aspects now together characterize what you know, right? Now, when you go past transactions, you have other non-transactional signals of intent. The weakest being that the customer probably browsed a product page or a category page. Then you could have cases where a customer wish listed something or put something on a watch list. There could be cases where somebody added something to a cart but did not buy. But as long as they're not plonking cash down on the table, it's still intent, it's positive intent, but not necessarily to the extent that a transaction is. So understanding that difference matters, but still understanding that there could be stronger and weaker signals makes a huge difference in being able to understand how do customers interact with products. That's your base layer, that's your data. Now, on top of this is where you have your algorithms. Now, your algorithms typically approach problems in the following ways. And I'm going to give you a very intuitive one-line explanation for each of these and then delve into a couple of these in a little more detail. You could say that one way of thinking about recommendations is to think in terms of how do people relate to other people or customers relate to other customers. In other words, customers like you did so and so can be a basis for recommendation, which means that if I take any given customer and I say, who are the people with similar behavior, I can use their behavior as the basis for my recommendation. Okay. A second could be you like so and so. Okay, so you bought a bunch of products or you've browsed a bunch of things, and there tends to be a common strain along those things, right? For instance, if you were to look at Obama's suit purchases, you'll probably find a preponderance of gray. Okay, because he's just said, listen, that's one less decision I have to make every day. Okay, and if you look at Mark Zuckerberg's preferences, you'll probably see a preference for hoodies, right? So sometimes people have preferences that go across multiple things. In QSR, it could be whether or not you're a vegetarian, right? So you have preferences that can come out across multiple interactions with the products, and that can give me an idea of what it is that you like, and then I can double down on that. Then I can also look at complementarity. People who bought A also bought B. Okay, so people who bought shirts also bought trousers, whatever, right? Diapers and beer, to take a classical example that used to be taught in data mining courses from years ago, right? So you could look at that. Or your strategy could just be hey, a lot of people did this. So there'll be times when something is trending. And this is sometimes very useful when you're looking at things like seasonality. Okay. And in India, for instance, festival season. So you want to know what was popular during the last festive season. Okay. All of those become useful. Now, each of these is a slightly different strategy. Customers like you did this. You like this, therefore I'm recommending this to you. People who bought A also bought B. This is what everybody is buying. And then I could also have a strategy that says, let me combine these and then put them together into like a single recommender list. That's what we typically call a hybridizer. Okay. Now, it's very tempting to think of the hybridizer as the one ring to rule them all, but it's not really always the case. And we'll talk about that in a bit, right? So you have all these strategies, and now you need a mechanism to take whatever these strategies produce to the customer. So you need like a use case layer. So when we talk about the use case layer in a bit, we'll talk about how some of those may be a little different. So your algorithm layer is where all the fancy math happens. The use case layer is where you're starting to link it a lot closer to your business case. Okay, so when we talk about the use cases, we'll talk about some of those. So what we'll do is let's just go into a couple of these algorithms in a little more detail. Okay, so here is an example of what we call the genome model. Oh, you'll see us using the word genome all over the place. Okay, it's I think it drives the biologists a bit crazy, but I'll try and add other things to make the physicists and the chemists also a bit crazy, as you will notice. Okay, so you want to build a model that says, hey, customers like you also did this. What's a good way to do that? The first thing you need to know is to say, how do I characterize each customer? Which is what we essentially call a customer genome. So your customer genome could have a whole bunch of things that you start putting in. Okay, so you could have within your customer genome, you could have information about their purchase behavior, right? What's their active period? How frequently do they buy? Okay, what's the total monetary value during the active period? Favorite day of week, month. Okay, a whole bunch of these other pieces of information, right? So that have to do with the kinds of like basic RFM type variables and something to do with the time of purchase and so on. I could also look at, say, store and channel preference. Do you have a preference for a particular branch or a particular store? Okay, any socio-demographics that I might have. If I have a lot of information about socio-demographics, I might as well put all of that in. I could have information about price preference, say product and category preference. Do you have a preference for color? Do you have a preference for a particular brand, a particular category, a particular subcategory, and so on and so forth, right? All of this becomes useful. I could also put in something called entropy. See, I told you, we were also going to make the physicists and the chemists kind of nuts, right? What are we talking about in entropy? Here's the thing, right? Let us say I went to a store. Like I said, in apparel retail, you will very often find that your customers, your offline customers have come once and bought one thing. Let's say you're a menswear chain. I've come in and bought a blue shirt. Yeah, sure. It's valid information. It tells you that I bought formal wear. It tells you that I bought blue. But in reality, it's one data point. Not to mention the fact that every working age male in the history of working age males since the Industrial Revolution has bought or owned a blue shirt, right? So, as a starting point, it's useful, but you can't put all your eggs in that basket either, right? So one of the things you also want to track is what is your uncertainty or your level of confidence in whatever you do know about your customer preferences. Okay, if you've done one transaction, you could argue that there's not a lot that you know. So to just take a small technical detour, imagine that I had a completely even distribution across all colors and I bought blue. Now I can say that my preference for blue is just bumped up a little bit. My preference for all the other colors is bumped down a little bit. Okay, now that's all I know. If I buy 5 shirts and they're all blue, my preference for blue should have bumped up a lot more and the others should have gone down a lot more. Okay. So that essentially is reducing the entropy in my understanding of preference, right? So we're using basically measures such as Shannon entropy and so on. We're sort of adapting it to this, right? So what we're really doing is we're saying the more you do something, the stronger my confidence in whether or not you have a certain preference. Now, it could also be that you've done a lot of transactions, but they're evenly spread across all attributes. Let's say I buy every color in the universe. Okay, I've just bought one of them twice. Okay, it is my favorite color, statistically speaking, but my confidence in that ought to be low because I'm buying everything, right? So there's a bit of that, right? So entropy sort of measures that and also becomes a useful thing to put in. So when I consider all of these factors, I now have what I call a customer genome, which is a way of characterizing my customer across a whole bunch of attributes. And this could run into the hundreds, right? And depending upon how I sort of chunk it and put it in bands, my eventual data, if I think of it as a binary string, could run into several thousands. Right. Now I could say that each customer is the center of the universe, and I'm going to ask myself, given that this customer is the center of the universe, who are the customers who are similar to this one? Let me draw a circle around that customer. So this is not the same as say segmentation, where you're starting off with your entire bunch of customers and you're saying I'm breaking them down into segments. All customers within a segment are similar. It's true. It's a valid approach. It's quite computationally economical. It does have the additional challenge though that there could be two customers in the segment who are geometrically speaking at opposite ends of that segment, basically. Okay. Are they similar? Yeah. But it could well be that for one of those customers, the most similar customer is actually sitting in the next segment. Okay. So if you make each customer the center of the universe and you find their lookalikes, you obviously can potentially do a much better job. Okay. That's essentially what lookalike modeling is. Now, there's going to be some fancy math involved in terms of figuring out how you do the comparison, what are the weightages you use, and so on and so forth, what kind of similarity metric you use, what are your weights for your various attributes, and so on. But all of that is just the math. The intuition is I characterize each customer, then I take each customer as the center of the universe, find their closest customers, nearest neighbor approach, or whatever you want to call it. Once I know who my similar customers are, that becomes my basis for recommendation. Okay, so I can take what these similar customers have bought that this fellow has not bought and ask myself, based on say what these other people have bought, can I now come up with, let us say, a weighted score for each of these recommendations that then tells me which is better and which is worse. Broadly speaking, minus the fancy math, right? This is the approach. Where is this very useful? It's very useful when you actually know very little about a customer. Let's say a customer has just come done one transaction. Okay. Somebody who's done two is now somewhat close, or somebody who's done just one transaction but matches on a lot of demographics, and we tend to believe that demographics matter in certain domains. It's very useful, right? So it gives you that slight bump to move to the next step, especially when you're talking about customers for whom you have very little data. It's not cold start, but not very high temperature start either, right? So that's essentially what the genome algorithm is. Okay, it's a way of saying what are customers like you doing and what do you do? Now let's take preference vectors. How does preference vectors work? Preference vectors works by saying, listen, I need to look at my customers' transactions and I need to say, if this customer has done a bunch of transactions, can I now look at say what they've done and find patterns across this? So do they have a preference on brand? Do they have a preference on say category? Do they have a preference on, let us say, subcategory, and so on and so forth? So when I have that information, I could essentially take all of that and say, hey, this is the customer's preferences across a bunch of things, across a bunch of product attributes. So this now allows me to say, hey, these are the kinds of products I can recommend that also match these preferences. Where does this become useful? Product cold start. Let's say you have a new product that you've launched. Whom would you recommend it to? Let's say there's a new K-drama that's coming out on Netflix. Who do you recommend it to? You recommend it to the people who've had a habit of watching K-dramas. It's the most obvious sort of first point, right? So it's that. How do you determine that? You determine it by saying, hey, this is the attribute that matters. These customers have shown a strong preference to watching K-dramas. So let me go put it in front of them, right? So it's that sort of thing, right? So content-based personalization, looking at the attributes of a product and saying, therefore, let me pick this. Okay. IBCF is your co-purchase patterns, right? So people who bought A also bought B. I could have a variety of ways to find these product associations. Then I could take a particular customer and I could say, hey, this customer essentially bought, say, the following items. Now, what went with these items? Okay, what are the products that went with these items that other people bought? And then I can put it together and say, therefore, I'll recommend this. Okay, in a QSR sort of context, I could say, hey, people who bought burgers also bought fries. People who have bought milkshake also bought fries. Recommend fries. It's just that, right? So essentially, these are your broad approaches. Trending is very obvious. Trending is just what's popular. Now, I could break that down by demographics. I could break that down by a time period. So I could say, hey, just before Diwali in a particular, I could say what was popular during Diwali the previous year. Okay. or what was popular during the festive season the previous year, right? So I could have ways in which I could measure this. If there are seasonal purchases like winter wear and so on, I could say same time last year what went on and so on and so forth, right? So trending is fairly obvious. Now, given that you have these things, one of the things you could do is to say, hey, I need like one thing that combines these strategies, so that if I just want to say, here are some recommendations for you, what do I do? So what are the factors that you would consider if you wanted to do that? One is very obvious. If the same product is getting recommended by multiple strategies, then maybe there's something to it, right? So there may be a good reason why, no matter what your approach, and intuitively these seem like very complementary approaches, no matter what your approach, certain things seem to bubble up. Okay, so then it should get a higher weightage or a higher rank. Now, if these algorithms feel very strongly about that recommendation, they're number one ranked by that algorithm, then again, give it a higher weightage. The third factor is, do you trust the algorithm itself to have done a good job? For instance, let's say you were free this weekend and you asked two people to recommend something to you. Okay, you asked me and you asked one other of your friends. I recommended, let's say, an arty sort of Malayalam film, and somebody else recommended, say, Dhurandhar to you. You ended up watching the two, and let's say you ended up liking the arty Malayalam film a lot more. Okay, let's say that's your jam, basically. Okay, the next time you have time only to watch one film, you're probably going to ask me because my tastes match yours better. So I can take each of these algorithms, for instance, and do a passive evaluation. I could go back in time by a month and say, knowing what I knew a month ago, what would these algorithms have recommended, and then compare it against what people actually bought to see whether or not they did a good job of predicting what people might buy. And that track record can then be quantified and become one of the factors in determining whether or not two algorithms that recommend the same thing, how do you weight what they recommend? One algorithm thought it was a great recommendation, another thought it was very bad. Do you think it's great or do you think it's bad? Right? The track record tells you that. The last thing to consider is also whether or not something is getting recommended to everybody. Okay, if something's getting recommended to everybody, then maybe there's a reason to discount it a little bit. Okay, in say natural language processing, like classical natural language processing, before people said, oh, let me just throw it into an LLM and see what bubbles up. People used to talk about something called the term frequency and the inverse document frequency. So if a particular word appeared very often across documents, you sort of discounted its importance. It's the same concept, right? So again, how much you discount it is a sliding scale that allows you to determine how much you want to personalize. So one of the things you need to remember is that with recommender systems or with any of these systems, there is a tug of war between exploiting and exploring, right? The exploiting aspect, the easiest way to exploit is to say, hey, I will just recommend the bestsellers all the time. It's not a bad strategy. It'll work pretty well. There are certain domains where it's a very, very hard strategy to beat. Like in grocery, it's very hard to beat the bestseller recommender, right? Because it just is a very obvious thing to do. Okay. And because patterns of people's purchases very often have that stability, and so it works well. Exploration is what allows you to personalize. Let's say a particular person loves purple polka dot party shirts. You'll never get it if you just looked at bestsellers. You need the ability to personalize to their data. Now, how much you personalize is one of the factors that you consider, right? So essentially, it's a tug of war between those two. So even when you're building hybridizers, one of the factors you might want to consider is, hey, is everybody getting this? Or only some people getting this? If everybody is getting it, maybe discount it a little bit, like give it a lower rank, right? So that's broadly speaking how you can approach recommenders in general. But as I said earlier, people don't approach consumption in one way. They approach it in many ways. So let's say I have a hybridizer and I have a bunch of recommendations. I haven't already solved my problem. I need a way to put them together, right? In a manner that is aware of the context in which I'm talking to people. Right. Now, like I said, I have like a one-line definition for each of these, like a lookalike based could just say people like you also bought this. So I could send out a message to people, or I could have a widget on my web page. That's it. People like you also bought this. Problem solved. Right. So some of my strategies could directly derive from the individual recommenders. And if I have a hybridizer, I could also have a strategy that just says, hey, here are some top picks for you. Safe, right? So you've covered that. But I could have something that's a lot more specific, okay, in terms of a business case. For instance, I could have a strategy that looks like this, right? let's say I want to double down on a customer's favorite category, right? So you have a particular category that you always buy in and I want to double down on that. So I might want to do that. Doubling down on favorite cat sounds like a Taylor Swift song. No? So let's say, and I could do my recommendations at a product level, brand level, and so on and so forth. So let's say I want to double down on a customer's favorite category. Okay. I might start off saying, hey, Hybridizer is fine. Okay. Good to go. Okay. But now I could also say, hey, don't recommend something that this customer has already purchased. And also do the following, right? You basically pick the category, okay, and you make sure that this is the customer's favorite category. So now what happens is, for somebody whose favorite category is, say, smartphones, they're getting more smartphone recommendations. For somebody whose favorite category is refrigerators, they're getting more refrigerator recommendations. From a practical campaign design standpoint, what it allows you to do is to say that there are times when you can essentially promote a whole bunch of categories and can be personalized in that, but your messaging can just be generic enough that you don't have to run campaigns for each of your individual categories. Okay, that then allows you to solve the problem. Okay, now one of the other things that you can potentially do is just shuffle the top recommendations, because in some cases you pretty much get the same recommendation for a whole bunch of people, because a lot of people may have had like very little behavioral cues and they're all very similar. Okay, so just shuffling it gives you a little bit of variety. Okay. It also allows you to explore to see whether or not something that you thought was lower ranked might actually end up being the one that people clicked on and so on. Okay. What you might also want sometimes is a fallback strategy. Let's say you have a bunch of recommendations. Let's say you had 30 recommendations that you stored in your system, and in the customer's favorite category, you only had 5, but you wanted to send 10 total. How do you fill the other 5? You could provide a backup by saying, listen, the other 5 I will just fill from popular. Okay. In some cases, you might say, if I get only 3, I'll just send 3. So you have the option to do that. What all of these allow you to do is essentially say that, hey, I have a very specific kind of business case. Okay. And I want to build that connective tissue between what my recommenders have produced and what that business case is. Stories are that connective tissue. It's what allows you to then talk to customers about specific kinds of approaches to consumption. So if you want to double down on what the customers typically buy, this is the way to do it, right? So this then allows you to build that kind of a recommender list. Okay, so for some customers, what you might get is a list that is very, very sort of, so if you were to use Genome, for instance, as your story approach, then what you might get is, say, a set of recommendations that go across a bunch of categories. Okay, whereas for, say, a different domain, you might get something that is, say, so if you use Genome, for instance, what you might find is, say, some degree of skew. And the reason for that skew may be because you have a lot of customers who essentially done very few transactions. So their lookalikes end up being very similar. And because of that, the things that you recommend to them end up being very similar. So you do expect a certain amount of skew. And skew is a good thing. Okay, you don't want like extreme skew where everybody is getting the same thing, but you also don't want no skew where everybody is getting very different things. That's the exploration versus exploitation trade-off that you want to manage. Okay. Now, depending upon each of these strategies, you may get results whose distribution looks very different. And it then also gives you a sense of what is the effectiveness of the strategy in terms of personalization and so on. So the one other thing to talk about is personalization itself, right? So how do you think about performance itself? Okay. So when you want to talk about performance, okay, you could talk about analytical performance. Like I said, you could talk about things like precision and recall and normalized cumulative gain and discounted gain and so on, where what you're really looking at is, hey, I recommended so many things, the customers bought so many things. How do I compare these? Now, I could do this in a passive manner. Like I said, I could go back a month and I could say, given what I knew a month ago, these were the recommendations I produced. How did they compare with what people did? So I can also calculate a bunch of these metrics like that. But I could also look at some very specific things like a nudge accuracy, which is how well did this nudge work? I sent out messages about a certain kind of recommender to a bunch of, using a certain kind of recommender to a bunch of people. How well did it work? In how many cases did people buy the same product? Okay, that could be, let's say, about 10%. Okay, in how many cases did they buy the same category? Now that could be a lot higher. In how many cases did they buy the same brand? That could be somewhere in between, right? So depending on say whether you're interested in breaking it down by story, which is your use case layer, or by algorithm, or by say event, basically the outreach campaign and so on, you could essentially look at how this data varies. Okay, that then allows you to sort of understand essentially what works, what doesn't out there, right? So remember that, like I said, not every consumption strategy works equally well, right? So doing this also gives you a sense of which strategy seems to work well or better, which strategy doesn't seem to get much traction at all. And then you can slowly underemphasize those strategies, overemphasize something else. There's also a formal way of testing this and trying this out, which uses say techniques like say multi-arm bandits, which automatically allows you to adapt your campaign or outreach strategy so that you're over-indexing on the things that work while still under-indexing the others and keeping the door open to see whether or not things change. Right? Again, exploration versus exploitation. Always the thing to remember is you don't know everything. So keep the door open to learn more, right? That's the idea. So you've got all of these. The one other thing I want to talk about briefly when you do all of this is how does all of this play out when you're doing online sort of recommendations, right? So let's say you have a website that looks like this. You have an apparel retail website and you want to, recommend a bunch of products. Okay, so you also want an ability to say customers like you bought this, trending, picked for you, and so on and so forth. What you want to do is to be able to recommend a whole bunch of products when customers essentially say customers are essentially on the website, right? So you might want to then say, hey, my lookalike algorithm is telling me this. Are you calculating this on the fly? No, you can pre-compute this, right? What's trending? Pre-compute. Okay, picked for you, hybridizer result, pre-compute. Okay, but at the same time, I can also go back and say, hey, based on your browse activity, this is what makes sense. Let's say the last few times you were browsing, you're looking at televisions. I can say, based on your browse activity, this is what happens. Now, this can be real time. So now if I spend some time looking at refrigerators, okay, and I looked at a few refrigerators and I essentially say, clicked on a few, I wish listed something, okay, and I put something on the shopping cart and so on and so forth. And then let us say I go back and I look at, what is based on my browse activity. At this point, it ought to change a little bit to include refrigerators because now I've given a signal that says, hey, people are doing this, right? So over time, you can learn. So this is something that needs to have real-time computation as well, but it doesn't mean that you compute everything in real time. You just need to be able to update your understanding of customers in real time. Okay. So one way of thinking about it is that your use case layer is essentially what determines what these widgets are. Each of these widgets is basically one use case. Okay, is essentially one story. Picked for you is the hybridizer widget. Based on your preferences, the preference vector. Based on your last bought product, what am I doing here? I'm saying I want to look at product level associations, but I want to see how do those associations work with whatever this customer bought last. Okay, that then allows me to build out the story saying this customer last bought, let us say, some kitchen appliance or some home appliance. These are the products that other people have bought when they also bought this. So I'm essentially using the co-purchase pattern, but I'm conditioning it on the last bought product so I can build a very specific business case around this. In apparel, how does this work out? Hey, we know you, I'm sure you love the formal trousers that you bought from us last time. Here's a great line of formal shirts that come out that might work well with it, right? That sort of thing, right? So there's a way of essentially building business cases around online as well. Okay, what this allows you to do is to determine when do you respond in real time, when do you respond in batch, and how do you make sure that a customer's overall experience is more customized. Again, we're talking about the very plain vanilla way of doing things here. There could be something a lot more sophisticated where you're essentially building, say, a shopping assistant, which is, let us say, more conversational, more agentic. Okay, and that could allow you to talk to customers in a variety of ways, right? That could essentially lead the customer through the website or through your product portfolio in a manner that is very personalized and sort of not just captures what you know about them, but also understands at that point in time what is the approach that works best. Okay, now let's just get to the elephant in the room. If we're going to have a data science related conversation, if we're going to have an analytics related conversation today, one of the questions that gets pre-asked is, what about Gen AI? So let's talk about how all of that matters here, right? One way of thinking about generative AI here is, see, very often when we think about generative AI, we're thinking about large models, right? Large language models, image models, and so on. Okay, and either you're going to have to pay API costs in calling something that's hosted on the cloud, or you're going to have to host it yourself and then take care of its care and feeding. Okay, which means one of the factors you need to consider is that the best way to use some of these is to figure out, are there situations where I can get a lot out of it when the usage of it scales not with the number of customers or with the number of interactions, but with something else. Okay, or if it can give you a lot of information with a little interaction. One example that we're building is something called Lens. Okay, so what we're doing here is, so let's take an example, right? Because we did a lot of the rings, I'm just going to say Frodo Baggins now. Okay, and let's go to images. And let's take one of the Frodo Baggins images. So let's take this guy. Okay, and I'm going to ask Lens to characterize this. Right. Okay. So this is a fairly straightforward thing where it's just going to take that image and it's going to analyze what are the attributes of the image so that it now says, listen, this is jacket and outerwear, and it's coming up with a bunch of things based on what it thinks this image is. Okay, now what this then allows me to do is essentially understand my product portfolio a little better. So if you have products and you have a bunch of images of your product, okay, how do you then pull information out? I could then use something like Lens. So I could say I have a website, I have product images, but my database contains only a limited number of attributes about my product. I could go there and say, hey, now understand all of these images. Tell me what is going on. And then it could give you a bunch of information about these images that then allows you to enrich your product master. And when you do, you can then incorporate it into your recommenders and into your personalization strategies and make a lot more of a personalized case in terms of how you talk to your customers. So that's the strength of something like a Lens. It then allows you to build out a bunch of stories. Right. So broadly speaking, these are the kinds of things that you can potentially do. Okay, when you want to essentially use a recommender system in your business. So you have a bunch of algorithms, a whole bunch of approaches. Once you have these approaches, you build a use case layer which builds the connective tissue between your approaches to recommendation and people's approaches to consumption, your customers' approaches to consumption. And then you basically link that to either your web or app experience, or you link it to your campaigns by saying, listen, hey, I'm defining a campaign where I'm going to talk about a category. Let's say I want to promote menswear. You go in there and you say, I want to create a story that just focuses on menswear, filter out recommendations down to menswear, and tell me what should I promote to each person. Okay, filter out recommendations based on kids wear, tell me what to promote to each person. So it gives you an option to do that. What then allows you to do is build very strong connective tissue between your recommender and your outreach strategy. Okay, it then allows you to personalize your interaction in a far more dynamic manner. Okay, rather than just say, hey, here are some recommendations for you. Okay, broadly speaking, these are the kinds of things that one might want to think about when one comes to recommenders. Okay. Now, obviously, this is not the end of it. You're going to keep building new stuff. For instance, when it comes to Hybridizer itself, one of the things that we are building is, and I kid you not, it's called the two-tower recommender system. I know it sounds like another Lord of the Rings reference, but this is really what it's called in the literature. Like YouTube and a bunch of others actually use this, where one tower essentially describes customers, one tower describes products, and then you have a machine learning layer on top that determines how to combine these and figure out how to score customers vis-a-vis products, or products vis-a-vis customers, and then say, these are my recommendations. Okay, you could have generative AI based methods that go in. There are transformer based methods that allow you to build recommenders that think of the next transaction just like a transformer system and an LLM thinks of the next token to put in front of you in a chat sort of interface, right? So there's a whole bunch of other stuff that goes on here, but this hopefully will give you an idea of what a recommender system is like. Okay, there's a data layer, you have algorithms, you have stories, and this is how they all come together. That's all we've got. Thank you. We're open for any questions. Okay, so Priya has a question that says, I see immense applications in retail and associated sectors, but what about others such as say EdTech? EdTech is one where you already see a certain number of applications. One example is when it comes to one obvious example is when it comes to platforms that provide online courses, like a Coursera, for instance. You do see it, right? So one very obvious case is in places like Coursera, where you do see people using recommender systems. Okay. The other possibility is when you're defining learning pathways for kids. Okay. And you see a preference either for a certain kind of content or a certain way of presenting the content. Okay. Now, a lot of it also has to do with being able to figure out certain aspects or certain characteristics of these products. But supposing, give you an example. So let us say I could take a concept like neural networks, and I could explain it from the standpoint of an electrical engineer. I could explain it from a standpoint of a statistician. I could explain it from the standpoint of a Bayesian. Okay, I could explain it from the standpoint of, say, somebody who understands it very geometrically. Let's say a particular approach resonates better. The next thing I talk about, I could say, listen, a geometric intuition works better for this person, whereas a Bayesian intuition works better for some other person. So it's also possible to think of next best action in some of these cases to be driven by aspects of that nature. Okay, I hope that answers your question. Please do feel free to reach out offline if you want anything further to discuss. What types of user data signals are most reliable for building high quality recommendations for a hotel or hospitality industry? For the hospitality industry, there are a bunch of signals, right? One is, of course, the stay itself, but certain characteristics of the stay might be useful. Okay. Some have to do with the booking itself. Are you the kind who books well in advance? Are you the kind who books during peak shoulder or off season? Okay. Are you the kind who books a certain kind of room or, picks a certain class booking? Like, would you prefer something that is non-refundable versus refundable? Do you prefer to book from an aggregator or directly? Okay. I could also be looking at say signals around, say, your past stays. For instance, do you buy other stuff while you're there? For instance, supposing you're the kind who uses laundry, right? If you're the kind who uses laundry services while staying at an upscale hotel, that's a very, very strong signal and it's very useful, right? It gives me a much better sense of whether or not you tend to be a high value customer. So broadly speaking, the characteristics that one tracks when one looks at recommendation, when one looks at travel and hospitality, are things like price sensitivity, schedule sensitivity, comfort sensitivity. Okay. So a lot of these will come out through certain other attributes, like how many days in advance do you book? What is the class of room you book? What is the class of payment you want to take, something that's refundable, non-refundable, okay, and a whole bunch of these characteristics. So those then allow you to define the kind of signals that you want to track, that then become very useful to build. The other thing to consider, if you're an aggregator, is the choice set. So when we think of what users buy, right, online, for instance, one of the useful things that we can do is I looked at 5 different items and I bought one. Okay, so I have defined my choice set from which I've picked something, and it's very useful to do that, right? In the hospitality business, similarly, defining a choice set becomes useful. Okay, if you're an aggregator or if you are basically giving people a set of options, you can also look at it in terms of, hey, you had this set of 5 different options that could apply to you. Okay, you picked this one. So now it also gives me a sense of whether or not there are certain preferences that you have in terms of the characteristics of these products that I can then infer from this, and that becomes a very, very useful signal to add to your models. Okay. Harshal has a question around how do you address recommendation and persona prediction challenges for one-time or long dormant customers with limited behavioral data? Very, very good question. So this is your cold start or your near cold start sort of problem, right? So what then happens is that when you have long dormant customers or one-time customers, is that your go-to strategy to begin with tends to be slightly more generic. Okay, like you could have specific and generic strategies. So one is, for instance, something like the genome works well when it comes to understanding how dormant, long dormant or one-time customers behave. Like historically, we found it to work well, right? Trending itself is a good strategy to start. Okay. Preference vector, where you combine user preferences with a limited proportion of crowd preferences and then slowly scale that down as you know more about a user, helps. But the key again is not the recommendation strategy itself, but the plumbing you build around it. So you have a bunch of strategies. You're going to have to try these. If you have a digital presence, then you try it online and you see what do people respond to. Okay, this is where you start collecting signals. When you have less data, a good place to start is to say, I'm going to try out a few things and see what works so that I can then collect more data. Okay, so in general, okay, in any complex system that's driven by data, you have only two currencies that you can pay with. One is data, the other is domain knowledge. If you have a lot of domain knowledge around your long dormant customers and so on, you use that. In certain domains, it's possible. Okay. Otherwise, you need data. And if you don't have a lot of it, you start collecting it by trying out a few strategies, seeing what works and collecting maybe non-transactional intent signals if it's possible, and then using that to slowly build. Okay. And then that gives you a starting point to get a lot more specific. Okay. Maulik has a question. There was a mention of need to often reduce granularity by looking at attributes. Example of a few use cases you have in mind. In apparel industry, small change in pattern changes the preferences completely. The level of granularity required can be tricky to decode. Yes and no. In the sense that there may be a broader pattern. So let's take an example, right? So if we take color versus pattern, for instance, like there could be very small design attributes that change. Like, somebody may have a self-patterned dress, whereas somebody else may have a pattern that looks like plaid or a whole bunch of these things, right? Now, what happens then is that, yes, your preferences do change based on this, and it's useful to sort of track that. What it helps to do is to do some analysis around which of these preferences are more important to my customers, which of these are less important. Okay. One very simple rule of thumb would be something like this, right? That let's take the example of apparel. If you have a preference for, say, solids over checks, okay, but you buy a bunch of colors, okay, then the fact that there's a lot more entropy on colors, a lot less entropy on pattern, gives me an information that that's a more important attribute and it is something that I need to track more closely. So across either your entire portfolio or across customers or segments of customers, I can track and figure out what are the attributes where the granularity matters more and where are the attributes where the granularity matters less. And then I can plug that into the kind of recommender strategy that I build. So certain attributes, like people may have category preferences and they keep buying in the same category. They may have color preferences, they buy the same color, but subcategories, they may be all over the place. So that might tell you that these are the things that you need to consider more important. And in these, okay, the way you think about granularity may be very different from the way you think about granularity elsewhere. And it can then feature in the way you build your recommender system. Okay. It's not so much the number of distinct values there are, it's a function of whether people have preferences that are exhibited in those, and can that feed back into how much importance you give to granularity on something versus loss of granularity on something else. I hope that answers your question, Maulik. Can you explain why a particular recommender was chosen for a user at a given moment when competing versus other recommenders? Is there an option to override the recommender in the future? Okay. So the context determines how this question sort of plays out. Okay. Now, when you're dealing with an app or web experience, right, when you're essentially providing recommender widgets on a website or in an app, you typically have room to try out a bunch of these widgets. Right? You could have a widget around the genome algorithm. You could have a widget around IBCF, a widget that's around, say, the preference vector algorithm and so on. Right. You have like classical collaborative filtering algorithms. You might have something for that. So you could have a bunch of widgets that you put in place, and you could track what is the response for those widgets. You could track whether or not people are just scrolling through it at all. So you could take those engagement metrics and figure out what works well and what doesn't work well. Okay, that's in a live sort of interactive case where you have an app or web experience. When you're starting off and you just built this, a way to figure out what works better, what works worse is to do the back testing. You go back in time and you say what worked better for what kind of customer. Okay, and that's something that you can simply do by going back in time a month, generating recommendations for a bunch of people, comparing it against who bought what, and then saying, for these kinds of customers, these algorithms work better. For somebody else, something else work better. And that's a good starting point for how you prioritize. Okay. When it comes to outreaches, you can essentially run a bunch of campaigns where your target sample is somewhat similar and your strategies are slightly varied, and the tonality and the wording in your message also varies according to your strategy. And you can figure out what do people respond to, what do people not respond to, and then on the basis of that, you can figure it out. Will there be a golden rule that says one will work better than the other? Not necessarily. There may be certain empirical insights that you might draw over time, such as, for instance, that preference vector works very well when you have customers who've done a lot of transactions, versus genome works well when people have done not so many transactions. Trending works well when there are seasonal spikes in behavior and so on. So there's a way to override whatever you understand when you're dealing with a particular target segment where you do have certain empirical knowledge that works. The rest of the time, you basically test and learn. And over time, you also allow for your learning itself to evolve by, frequently running that test to figure out, has something changed in that? Is there a benchmark that tells us whether our recommender worked, or is it set by us and then we push to improve it by improving strategies? The two ways to approach the problem. One is to essentially try your recommender strategy against a benchmark data set and sort of figure out how well it works. But that is more like a theoretical benchmark, really, right? How well your recommender worked is very often a function of how it worked on your particular data set, right? If I'm thinking in terms of analytical performance, if I'm thinking in terms of nudge performance, the easiest way to do that is to essentially look at the counterfactual. Okay, like using a particular strategy versus not using a strategy, does that give you a sense of whether or not it improves? Okay, that then allows you to slowly build on that. Okay, because it also gives you a sense of whether people's, see, the easiest way to benchmark something is to look at, say, trending, look at the bestsellers, right? It's the most obvious thing to say. Okay, so you could simply look at how well you worked against the bestsellers at a particular period in time and then compare it and see. And if you're running an app or a website, then it is possible to essentially have a certain proportion of your customers get the benchmark versus your strategy and then see what strategy works well and then improve from there. Okay, but it's also a function of what are the kinds of things that you want to track, that you might want to be okay with certain. The problem with the benchmark is also that it assumes that there's a particular number that you care about. Sometimes one of the things that you care about is to say, I want to sacrifice a little bit of my relevance in favor of becoming a little more personalized. Okay, so you might actually do worse against your benchmarks because you're becoming a little irrelevant and a little more personalized. So it's also useful to figure out what are the metrics you care about at any point. But the usual way to think about it is to think in terms of, had I not done this, what would I have done instead? Usually a good benchmark is trending. Okay, and over time, you can always improve a strategy, compare it against the non-improved strategy and see how it works. Does that answer your question? All right, let's call it a day. Thank you so much for attending. I hope this was useful and informative to you and will help you determine what strategies work for you in your own organizations.